suppose probability of A intersect B equals 0.4, probability B equals 0.9. Find the probability of A given B. So probability of A given B, this is a formula. If you get a formula sheet, that's great. This is the probability of A intersect B over the probability of B. So whatever letter is second is down here. Okay, so whenever you're given two numbers like this, really only two options. You either multiply or you divide them.
Okay. Gotcha.
All right, so let's look at number two. Number two, this is the probably more difficult version of this. All right, so probability of A given B is 0.7. So that is the probability of A given B is the probability of A and B over the probability of B. And so that's kind of there. And then the probability of A given B not, okay, or not B, is the probability of A intersect B not over the probability of B not.
Okay.
And they're giving you, what are they giving you here? Okay. What are they giving you? So we're trying to find probability. So that's not even in any of these. Okay. Let me, there's something here I'm not missing, or it's not clear to me. Maybe A and B are the only two events. This is a copy and paste from a homework that you did at some point. So let me see. I'm sure it's out on the web. So let's see if we can find this. All right. So this one did actually, I wonder, did it say to use a tree Venn diagram? No, it didn't. So yeah, I still don't quite see how this is supposed to help. Okay, well, now I sort of do. Okay, so the probability of B given A, I'm sorry, probability of, this is very, very much backwards. So the probability of B given A is this formula. It's the probability of B times the probability of A given B over the same thing. But then you have to go down this other fork in this thing, the probability of B not times the probability of A given B not. So if so they give you B, that's 0.4. The probability of A given B is 0.7. And then they give you those values down here also. And then B not here is 1 minus the probability of B. And then they give you the probability of A given B not down here, which is 0.5. So how is that helpful? Well, once you have this number, which we're about to get, that number is put in a calculator. Looks like it's like 0.48. The probability of B given A is then the probability of A intersect B over the probability of A. And this number here, 0.48, is the one on the left. A intersect B was given, no, we can find it. Because we just want the probability of A. Are we given that? No, we're not. Oh my goodness. Oh, we can find it from this relationship up here. We can use this one because A given B is 0.7, and then probability B is 0.5. So we can find this one up top here. It's if we call that X, it's 0.5 times 0.7. So this is 0.5 times 0.7 all over P of A. So then we can solve for P of A. So you can just swap places with these. P of A equals 0.5 times 0.7 over 0.48.
Okay, so you did you took the equation from the top, but you just switched the A and B.
No. That like this is the with the given information. We're only with the way the information is given. We have to go this direction
Okay,
with it.
gotcha. So what
I,
is
it-
the
I
what
mean,
did you do?
this one's pretty complicated. Like I wouldn't expect this to actually be on your test.
Okay,
I mean, I'm trying not to get out of this one, but it's there's a lot going on here that maybe isn't needed.
okay, gotcha.
So I can try to avoid those, but that's why I said like you're gonna have to pick and choose here because I don't know that we can get through all of these in
Yeah.
the given time. Okay, question 3. Actually, let me get down here again. Suppose you roll a fair die twice, and we want a 3 the first time and a 3 the second time. Okay, so the probability of rolling a 3 the first time, there's 1 out of 6 because there's only 1 3 on a regular dice or die, and then the second one is 1 out of 6. So and you generally multiply. So you multiply these two together to get 1 out of 36.
Okay, that's easy.
Do distinguishable fair die or roll. Let A represent the event that the red die is a 2 or 4. Let B represent the event that the sum of the two dice is 6. Find the conditional probability B given A. All right. So we need to first look at like what is A. A is that it starts with a 2 or a 4. So here's what could happen. Like you're in your sample space, things that like you care about is well, how do I want to explain this? So the given A, that's your sample space. You're looking for like all the possible ways that like what could happen. So there's like you could roll a 2 and a 1, that satisfies that. You could roll a 2 and a 2, and that satisfies that. The first one is A, and a 2 and a 3, and so on, all the way up to 2 6. But you could also roll a 4 1, a 4 2, and so on, all the way up to 4 6. So there's 12 possibilities for A. So this given A is like that's what you're like, well, what are the possibilities? Okay. So B is that the sum of the two dice is a 6. So how many of these actually do what we just said, in this list here? Well, there's 2 comma 4. I don't know where to put that. There's 2 comma 4. And then there's 4 comma 2. Those are the only two that actually work out of this list. So the probability of B given A is those 2 over the 12 that are possible.
Okay. Oh, I see.
So I think what may be challenging here is like knowing like what to actually restrict this to.
Yeah. Okay, so B is just the 2. Okay, I see.
Some of the dice is 6, yeah.
Gotcha.
See, the thing is though, there's a way to flip this question where it changes it all together. A given B is very different because then you're looking for all the possibilities of the sum being 6.
Gotcha.
Yeah, so it's not great. It's just there's too many variations. It's not like, oh, here's one problem and then let's do a bunch like it. Every problem has a little wrinkle to it. All right, so today the probability of rain is 0.3. And there's 80% chance of rain tomorrow. So here's the possibilities. Here's what could happen. It could rain both days. It could not rain and then rain. It could rain and then not rain, or not. And we want this last one.
Okay.
So like the first one is like 0.3 times 0.8. And the second one is no rain is 0.7 times 0.8, because it's either it rains or it doesn't. So it's 1 minus 0.3 to get that. The next one is 0.3 chance of rain times 0.2 chance of no rain, or 0.7 no rain times 0.2 for the last one. So the last one is the one we want.
Okay, so there's just a 0.14 chance
Yes.
for 14%. Okay, gotcha.
All right, so let's move on to the next one here. Moving on to a different section, Bayes theorem. Oh, we actually already did Bayes theorem for number 6.
Fine.
Probably would have been helpful to do that first. I don't know. Do you want to go through this one? I don't recommend it. I think it'll be clear on the next ones if we use Bayes theorem.
So just skip 8.6.
No, let's go to just question 7.
Oh yeah, no,
to
yeah.
do with that, because that'll be a little bit clearer here for this.
Yeah.
So 58% live in the West Hall and the rest live in the South Tower. So here, like, you got to figure out your break. Your break is west, and then south.
Gotcha.
So 0.58 go that way, 0.42 go the other way. Now it says a sandwich shop randomly mails a coupon for a free sandwich to 26% of those living at the West Hall. So if you're in the West Hall, your coupon is 0.26. Okay, and we assume that no coupon is the rest. They're the ones that don't get it. South Tower, kind of same deal, coupon and no. So the 19% get it, and then the rest don't.
Gotcha.
Is it clear how I wrote why these numbers fall where they do, why we broke it up into west south? Okay, so from here you can actually do the question, which is find the probability that this student does not receive a coupon. So which paths lead you to no coupon? Well, you could go west and no, or you can go south and no. Do you see that both of these are no coupon? Okay, so the west and no is 0.58 times 0.74, or, which is a plus, 0.42, that's the South Tower, and then 0.81.
So you just add those two together. The south and
yes, you find.
Gotcha, that's easy. Okay, that's simple. And then I think 8 is the same thing, but I can figure that out. I'm sure of it.
Okay.
So we don't have to do that one. And then 9, is 9 the same, or do you think it's more difficult?
It's slightly more difficult.
Do you think it'd be worth doing, or do you think it like probably wouldn't pop up?
Yeah, I just set it up. It
Okay.
won't take that long to set up. The setup is really the key thing. Like, the grade really should come from that, because the rest is just manipulating the numbers. So, all right. So there's 3 groups this time: A, B, and C. 0.4, 0.25, 0.35. 2% of customers in age group A made a claim. So it's claim or not, claim or no, claim or no, claim or no. Just putting the numbers in. So 0.02, 0.98, these have to add up to 1. 0.015, 0.985, and oh, I gave you I had the wrong numbers here. These actually move over here. It's 1% in group B, 0.01, and then 0.99. Now we actually get to the question. Given that a driver made a claim, what is the probability that the driver is from age group C? So we first need to figure out like the probability that they made a claim.
Okay.
So the probability that they made a claim is like going down A claim, B claim, C claim.
Gotcha.
So it's just getting these numbers together. It's 0.4 times 0.02 plus 0.25 times 0.01 plus 0.35 times 0.015. But we only care about which group. That's the given. The given is the like the bottom is the given, but which group do we care about? We care about whether they were in group C. So the group C, and this always is the case in Bayes' theorem, is you always have a replication. Like one of the ones on the bottom here ends up being in the top, and it's the one you're interested in.
Okay. Okay, that's simple.
All right, so move on to 10.
Yes.
All right. All right, 3 fair coins are tossed, and X is the square of the number of heads showing. So you have to know the sample space for tossing 3 coins. So it could be tails, 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 heads, and so on. Do you remember us doing this together?
Yeah.
Okay. So the hardest thing is probably just writing it all out. Heads. Let me go over here to this next row. Heads, tails, tails, heads, tails, heads, heads, tails, and then heads, heads, heads. Okay. So here there are 0 heads. And then when you square it, because it says somewhere you got to square it, square 0 squared. So this is 0. I'm sorry, that's the wrong place. That's 0. There's 1 heads here. There is 1, 2, 1, 2, 2, 3. So you count, like these are all the same. So 1 squared is 1, 2 squared is 4, 3 squared is 9. So you just count. There's 1 out of 8, that's 0. There's 1, 2, 3, 3 out of 8 for 1. And for 4, there's 3 out of 8 again. And then 1 out of 8 for 9. So the X row can actually add up to anything, but the sum of the probabilities of X equals X has to equal 1. So when you add up these numbers in the second row, it has to equal 1.
Okay. So
We did a bunch like that, and you may just want to remember the like this distribution here. It might save you some time after having to write all this out.
so why did you do 0, 1, 4, 9?
Because it was the square of the number of heads. So it's 0 squared. This is really 0 squared. This is 1 squared. This is 2 squared equals 4. And this is 3 squared equals 9.
So you're just taking okay, gotcha.
You're just counting the number of heads and then squaring it. It's more complicated in appearance than actual like what it is.
Okay, so wait. So you go to 0 and it's 1/8. I get
Yes.
the 8, why are we doing 1?
Because there's only one time that you get 0 heads or 0 squared heads.
Oh, duh. Okay, got it.
And then there's only 3, ones.
Yeah, and then there's 3, 2. Yep. Gotcha.
Yeah. Okay, can we move on to 12?
Yes.
Okay, so 12 is a problem I would think you would get on an exam. You first have to fill in the table. Once you fill in the table, you can then answer the questions below it. So as I mentioned in the previous problem, this bottom row has to add up to 1. And if you're not given this information that these are the same, you wouldn't be able to do it. Like you'd have to know something about them. So the short of this is that 0.1 plus 0.3 plus x plus 0.2 has to equal 1.
Okay. Okay, gotcha. So can those be the same number, like if that's, hold on. Okay,
So I'm
wait.
just asking you to solve that equation. So you're gonna, it's 0.2x plus 0.6 equals 1. Subtract 0.6, x equals 0.2.
Gotcha.
And I would go back and fill that in the table because you're going to use the table for part.
Sure. Okay. And then is this like, I can put this on my calculator, right?
You don't need to. This one, you're just going to add up. So like 2 less than x less than 10. We got to figure out which ones that's referring to. So let me just do a snip here of this. So you can, I can try to highlight which ones that is. So when you're doing 2 less than x less than 10, it's the ones that so that maybe this is a little bit unclear, but it's the 4, it's the 6 and the 8, but it excludes the 2 on the outside.
Gotcha. And you just add them together.
You add them together. 0.3 plus 0.2 plus 0.2 is 0.7.
Gotcha. Easy.
So now the next one here, it's probability that x is less than or equal to 6. So you include 6, but you also do the ones that are less than that.
Okay. So it's 6, 4, and 2.
It's 0.1 plus 0.3 plus 0.2. The x tells you which ones to choose, but you always add up the probabilities.
Yeah. I was just saying you do the,
Yes.
like, okay, that's easy.
All right, 13 is where we probably go to the calculator.
Okay.
So if you're ready, we can move to that.
Yes, perfect.
All right. So pay attention to decimal places on your exam. This one says 5 for some reason. Okay.
Okay.
So the on your calculator, you're going to do a binomial PDF.
Okay.
And I don't remember the order, but you can tell me what's in your calculator when you find it. I think it's second stat distribution.
And isn't PDF correct because it's equal to?
Yes, that's right. And that's because it's equal to 5 here. That's why we're doing this.
And then CDF is when it's like the greater than or less than symbol.
Yes, sir. Yes.
Okay. Okay. It says trials, p-value, and x-value.
So your trials is 7. P-value is 0.1 and your x-value is 5.
Okay, that's easy. Yeah, okay. I got 1.701, like e to the -4.
Okay, well that's.
So what would I do, like, because it's on paper and we have to like write it down, like what would you like think?
Like exactly what I've got here.
Oh, let me look, I'm on the other page. Oh, just that, okay.
Yeah, just this.
Gotcha. Okay. Think we can skip past any of those that are that simple because that's easy.
Sure. 15 is an at least if you want to do that.
Is that just the same
or
thing?
16.
CDF, correct?
It's a CDF, but CDF only gives you the left. So
Mhm.
like, you got to be careful. Like if you put 5 in your calculator, that'll give you the wrong answer because it'll do 5, 4, 3, 2, 1, 0. You would want to put 4 in your calculator and then subtract it from 1.
Okay, so if it's the greater than symbols like pointing to the left, then I take one less than
Yes.
what it's asking and subtract from 1.
Yes.
Okay, so I'm thinking. Okay, 15. So I use binomial CDF,
Yeah.
and then the numbers I put in would be 4.52 and 10.
If we're talking about number 15, it's 10 trials. So
Okay.
it would be 10, comma, 0.52, comma 4.
Okay,
Then you would have to do 1 minus that when you get that value.
gotcha. Okay. Okay, that's easy. Is 16 eat simple like just like that?
Yes.
So this
A is a binomial PDF because it's exactly 1. And then B is a CDF, but it says at least 2, so it's a greater than or equal to 2. So you would use 1 as your X value.
Okay, and this one is I would do 1 minus my answer, correct?
Yes.
Gotcha. Okay, easy. 17 is just generic, isn't it?
It's between 80 and 90. So again, like you got to be careful with your calculator because when you put in 90, 90 gives you 90 all the way down. 80 gives you 80 all the way down. So you actually want to do 79, 90, and then 79 to get the right mixture of numbers.
And then when I'd subtract those two.
Yes.
Do I do 1 minus those and then subtract those?
No, because it's between, so it's already giving you the left. Like it's saying 80 less than or equal to X less than or equal to 90.
So I just subtract the 79 from the 91.
Yeah. You do a binomial CDF, comma, 90 minus binomial CDF, comma, 79.
And I always do the bigger one first, correct?
Yeah. Yes.
Gotcha. Okay. That's simple. Okay, the 9.3.
Um,
18.
Sure. Get that snipped in here. All right. So far he has an average of 150 after 5 games. Okay. So what that means is that, and you tend to want to deal with sums in this example, but you can also look at it this way. He's bowled 150, 150, 150, 150, and 150. Because when you divide that by 5, you get a 150 average, right? So they want the average to be 152. So it's like adding another score here, dividing it by 6, and this equals 152. So you like before this extra score, you would just take 150 plus 150 plus 150 5 times and divide it by 5 to get 150.
So it'd be like 750x.
Well, you're adding these though, so it's 750 plus x over 6 equals the 152.
750 plus x. Okay. And then I just solve for x.
Yeah, and it's a lot bigger than you would think because you've already got a bunch of numbers, affecting it. So it's like 912 equals 750 plus x. So it's like x equals 162, roughly.
Okay, gotcha. Easy. So I find x, the expected value.
Yeah, so let's move on to at least, I guess we can do 19. It's pretty straightforward. I wouldn't expect this, but expected value of x is the mean. And in some, again, like when you only have two numbers, there's only a couple things you can do with this. So you have 50 darts and you have 0.2 as your probability. So expected value of x equals x times the probability of x. So there's 50. The probability of x is 0.2. So you expect to hit 10 of these bullseyes.
Okay. Easy.
Where it gets more sophisticated is that in 20 you have a table, so you have to fill in the values, and then you have to use the formula that we've done a bit of. So here again they tell you, okay, assume that these are the same. Like you got to find those values.
Mhm.
So save you the suspense. It's 0.2 again, just like it was in the previous one.
And then can't I just put this on my calculator and get those, because we can do it that way?
This one doesn't work as well. And the formula is pretty straightforward. You could put all the numbers in a list, but by the time you did that, it would have been faster just to multiply them. So it's -2 times 0.2 plus -1 times 0.2 plus 0 times 0.4 plus 1 times 0.1 plus 2 times 0.1.
Gotcha.
And that's your expected value of x.
Okay. So x is just, they're asking for 2.2, so that would be the value of x.
Whatever this ends up being, minus
What one
0.4.
thinks it asks for? Oh, gotcha. So it's just looking for the expected value.
Yes.
Easy. Okay. Got that.
Okay, next page here, 21. Could do that for sure. All right, so a roulette wheel. Don't know if you played roulette or know what it is, but it's a wheel. It's got black and white numbers 1 through 36, then two green numbers 0 and 00. A bet on 4 numbers pays 8 to 1. That is, if you bet $1, one of the 4 numbers you bet comes up, you get back your $1 plus another 8. How much do you expect to win with a $1 bet on 4 numbers? So there's two possibilities. One, your X here is that you win and that you lose. So what is the probability of winning? So if you bet on 4 numbers, that means you're picking 4 numbers, but there's 38 options. So there's a 4 out of 38 that you win.
Okay.
Lose is the other possibilities. It's any of the other 34 out of 38. Okay. Now instead of win here, we're going to replace that with what you actually win. You win your $1 plus another 8. So you get $8 in total. But if you don't win, your $1 that you put on the table is gone forever.
Gotcha.
So your expected value is still the same thing. Like even though this is in the context of a gambling game, it's still x 8 times 4 over 38 plus -1 times 34 over 38. So this ends up equaling 2 over 38 or 1 over 19. I'm sorry, negative. So you on average, you expect to lose like 5, 6 cents every time you play this game.
Gotcha. Okay, and then 9.4.
I'm sorry, which one do you want to just go on to the next one here?
Yeah,
Okay. This one is for sure a calculator.
perfect.
You're going to put this data into list one. Let me snip it in here. So you're going to take this list, and this goes into L1. You're just put all that data into L1. So 4.2, 4.7, 5.4, 5.8, 4.9. And then you're going to do a stat. I think it's a stat one variable stats.
Yeah, and then, yeah, gotcha. Okay. And then if I put all those numbers in, will that just give me my answer?
It'll give you out the answer. Yeah. Now it gives you a lot of things. So if you haven't done this before, it definitely would do it. You know, now just to be familiar with it. But yeah, I mean it's because there's two standard deviations it'll give you. It'll give you sigma, and then it'll give you S below it. You want the S below it.
Okay, do I put anything into, what do I put into L2?
Nothing.
Nothing?
Nothing.
Okay.
Oh, it does say you can only use the calculator method to check your answer. So I think you might be expected to do this by hand, but that's okay. Let me know what you get for a mean when you got this up.
It just has an error because I don't have an L2.
For one variable statistics.
Uh-huh.
So that's a mistake. That means that if there's something in your your calculator's interface, like looking for something in L2 without seeing your screen, I couldn't help. I would suggest clearing some things out.
Oh, because it asked me to okay, so it says list L1 and then frequent list L2. Do I just delete that?
Yeah, you don't have that for this one. That may have been what you were thinking of when you were using your calculator for some other stuff.
That was my problem. I just had to clear that L2 out of there. Gotcha. So my the sigma sign.
We need X bar because we actually got to do this by hand now, unfortunately.
X bar is 5.
5. Okay. So to do like the way this says, you can only use the calculator to check your answer. So what you have to do is X and then X minus X bar squared. So you have to take your value 4.2, subtract 5, and then square it and get that number. 4.7 minus 5, square it and get that number. 5.4 minus 5, square it and get that number. Now your calculator can kind of help, but you still got to write all these down. Just a little, slow. So you get these numbers here, and then you add them up.
Okay. That's just a long and annoying process for now.
Yeah. So there's more. So you get this number. Okay. And whatever that number is, you put it in the numerator. So it's summation X minus X bar squared over N minus 1 square root. So you take whatever that number is, that goes into the numerator. And then you have 5 samples. So it's 5 minus 1 down here on the bottom, or 4. And then you take the square root of all that.
Okay, so it's a square root of, so for the 4.2, I got 0.64.
Okay, for this one?
Yeah.
Oh, yeah. At this point, I can write some. 0.64 of 0.3 squared is a 0.09 0.16, 0.64, 0.01. So you add all those up, you get that number here. That number goes into the numerator, divide by 4, and take the square root of that. And you'll get the same number you got here when you did your one variable stats. So like you just have to do enough to show that you understand and then write down the correct answer from your calculator.
Okay, so technically speaking, I can get all those answers from the calculator, even
Yes.
without writing it all down.
Yeah.
Like, I mean, he asks for it, obviously, so I will, but
Yeah, it's an odd thing to ask. Like, you know, why would you ask a student to do something that the calculator can already do? But that you got to show enough to make sure that it's clear. Like, okay, this is the formula. I got the numbers, and here's the answer.
just to make sure that I'm like looking on the right things. So the S one is because they have it SX.
That's the one you want.
Okay, and then the other one's that symbol with an X.
Yeah, you don't want that one. And the instructor tells you that by saying up here, S sample, that's S.
Gotcha.
Population is sigma.
Gotcha. Okay. Okay, that's simple. Okay.
We have a limited amount of time here left. Why don't you pick and choose what you want us to do next?
One of the ones between 26 or like 28. I don't know, one of those between probably 26.
Okay, how about 27 or let's start with 28. That's the more common one to see.
Can't I just throw that into my calculator in the integral thing?
It could help. I'll try to explain how to do it. Although if you need to show work, that won't work. So let me at least show you. I'll show you how to show work. So this is the integral from -2 to 2, 8k dx. Okay, and this has to equal 1. Right. So now on your calculator, you have to. Here's what you do on your calculator. You do. Is it int? What is it? N-int? I don't remember what it is.
Yeah, I was trying to figure that out the other day.
Well, I can tell you for sure. I just need to pull one up.
Oh, FNINT. Yes.
Yeah. So you're going to do the FNINT. Okay. You're going to do 8 because you do not. The K is over here. You just comma -2, comma 2, comma I think X. I don't remember if you have to put that in or not. Okay. And this all has to equal 1. Now this is going to give you a number.
Okay.
Like it's going to give you like 32.
Okay, I'm confused as to where. So in my calculator, okay, so I'm confused on the K into the infinite thing.
The K doesn't go in the calculator. The K is just over here off to the side. So you do everything without the K.
Gotcha. So it's K and then times okay.
But don't put a K in your calculator. That's
yeah.
Okay.
And then I just plug in the 2, -2.
It's usually lower to upper, A to B. So it's got to be -2, 2. And then usually it wants the variable of integration.
Because when I put it in, it gives me the thing on the top, not the thing on the bottom.
Okay, well then put in everything except the K, like -2 to 2, 8 dx, and get that number.
Okay. 32.
32. So it's K times 32 equals 1. So you divide by 32K equals 1 over 32.
Okay.
So the thing is, though, is you might think, oh, I've got it. Like no big deal. 27, you have to use calculus because like if you go to your integral, here's what your integral is: 0 to K, 5x dx, and this is supposed to equal 1. And there is no like backwards int in your calculator.
Okay.
So let us briefly review this just in case. So the integral of then let me just move this 5 to the outside. 5 integral 0 to k x dx. There's a power rule. So to undo power rule, you add 1 to the exponent, and then you divide by the new exponent, bring the 5 down. So this simplifies to 5 halves squared, and you evaluate from 0 to k. So you start by putting in the top bound, then the upper bound, then the lower bound. So it's 5 halves k squared minus 0 squared. So that goes away. So it's 5 halves k squared. And again, this all has to equal 1. That was way up here in the beginning. Okay.
Yeah.
So now you know how to solve this. Okay. You multiply by the reciprocal, take a square root, so k equals the square root of 2/5.
Okay, that's not terrible, but not fun either.
No.
Cool. So like on 28, you had me obviously not put the k in. So say if on 27, if it was like 0 to 2, 5x d of x, do I put the x with the 5 when I put it
Yes.
in my calculator?
Yeah, you can do that.
Does it matter if I put that in or not?
You just have to keep track of it if you don't. Like if you don't put the number in, it's still there at the end.
Okay, so
Like if you, let's say it was 8x instead of k, you could put the 8 here, but you still get that number. Like it has to come with it. So I would just include it in the integral.
okay, so if it's x included, if it's not x, I wouldn't include it in the integral.
Here's what I keep hearing, and you got to tell me if this is wrong. So let's just say it's from a 0 to 1 dx. Okay. I would enter this into your calculator as is, but you could do 5 times integral 0 to 1 x dx, and you'll get the same thing.
My only confusion was because you took out, like, you just had me put 8 in. Is that just because it's not x? Is that the only reason you didn't include the k?
You have to put an argument inside there. Like if like the way you could have done this is really weird, but it could have been 8k integral 1 dx minus 2 to 2. But you got to put something in there. So like your calculator is expecting something in that position.
So I couldn't change that to like 8x dx. I'd have to.
No, that would be wrong. Like that would be really wrong. Yeah.
Any other variable besides x, I wouldn't include it.
Yeah, these are all written kind of the same. It says for what value of k or c, those are kind of commonly used.
How do I make sure to re-include it? You said if it's not x.
You just, well, I mean, if there's a number there, you put the number here in your integral. I would put the number. I wouldn't take the number out, I guess is what I was trying to get you to drive you to that conclusion.
Gotcha.
Okay, so really quickly here, normal distribution, that's normal CDF always. Upper and lower bounds, we did a bunch of those in one of our last lessons. You could take a look at those notes, and so on. And then 37 through 40 are the calculus ones. So we did one of those in your notes from last time. So maybe take a look at that if you are unsure. But unfortunately, I do have to stop here. I know there's more to cover, but I don't know when your final is, but if you need another lesson and don't see something available, just text me and I'll see what I can do to work you in for that.
Gotcha. Perfect.
Okay. Thank you so much for scheduling, and I'll see you next time.
Thank you. Bye.
Welcome. Have a great night. Bye now.